Now we come to binary tree. In binary tree, mainly we are going to use the stack. So first let's go and validate if our library is added here or not. Go to compiler, go to linker setting, we see that setting is there. So our lib is included. If I click edit, then I am able to see entire path. Say OK. So that means it is going to use stacks and queues. So for now, in this tree, I have inserted certain values. First let's see what is our tree looking like. So I want to make one tree and print it so that we can proceed with traversal. So I will be cleaning up our main. Why we are searching, we are inserting. So this not found I am removing. Print ASCII we want. For now we don't want any deletions. And in order also we can leave. So till this, if I run, it just created a tree and printed its in order traversal. Even traversal we want to keep, because when we write our traversal, we want to see it matches up. So now the first function that we want to write today is, let's start with level order. Right? So because it is traversal, what do we expect this function to do? Print all the values. So what should be the return type? Void. Level order traversal is the name. What will it take? And the data we want to print.
No.
Okay. Yeah, it just needs root. So this is the traversal we want to make. So one option is we go to BT node and we start adding our code. Second is, let's add a different file so that we can keep all the traversals that we are doing today in one place. So go to file, new file. We are adding a C file, and let's call it.
So we are adding header.
Did I click header? I'm sorry. New project. Sorry, no. New file. Okay, I go with red color. So yeah, it should be C file. Traversals. And we say all finish. So what we have got now is, we have got a traversals file. So in this we want to implement our function. If I hit a compile button now, it will give me warning or error. How do I fix that? Before hitting a compile button, I am saying just by writing this.
We have to include the header.
Includes hash.
What did not we declare?
We didn't declare the function, no, sir.
This function is
Header file.
added in the header, last line.
Includes
Hash include, it is using BT node. We are using a type which this file doesn't know where it is defined. So we have to bring the header file. Hash include BT node.h. Anything else? We are using just one type, function name. Fine, it should work for now. Let's compile. Let's see. Okay. It is saying for some other function, search function, it is saying control reaches at the end. That is previously implemented function. Probably in search, if we are not, for now let me put null here so that we don't go into it. So now it will compile here. So level order, yesterday we talked about how do we implement level order using queue. Level order we want one by one level. So other traversal, recursive traversal that we convert to iterative, then we use stack. So here we need a queue. So how do we create a queue?
by including that.
We have queue now. So it is not giving me suggestions. Why?
We didn't
Include into hash include. So let's first hash include our own queue file. Queue.h. Now we will be able to use our queue. It came star queue equals create queue. Done. Destroy queue also I should add right now so that we don't forget when we are writing other code. So So destroy we should do in the end. Otherwise, anytime we call level order, we'll be allocating but will not be freeing. So destroy queue will help us destroy it. So if we are not using queue after this line, then we don't need to make equality. Generally, this equal will make it null. Last line of destroy we are doing null. Now, what should be the first thing we should do?
Insert in the queue. NQ.
We should enqueue root first. So let's say enqueue two parameters. First is the queue in which we want to enqueue. Second is root, because now queue stores pointers. We are directly giving pointer. No, we want to store entire node. The reason we are putting is because this node knows left and right pointers. If we put data, then we will not be able to go to left and right children. That's why we are putting this. So this is first. After putting the root, what we do? We run a while loop. First thing we do is we dequeue. We take the first value out. In dequeue, the result that comes we'll put in, or we can use root directly. But, okay, just to avoid confusion, let's use 10. So what we are going to do is we are dequeuing. Dequeue queue. So we got first element out. After we get the element out, we have to print it. Percent D, because our value is this. Temp of data we are directly printing. So one space don't forget, otherwise it will print everything without spaces. So after we have printed enqueue temp left, because temp whatever we have dequeued, left of that we should put. Then we have to enqueue temp of right. With that, root is done. Now left and right they have been put in the queue, so that two parameters, q comma, because in queue we have to put, right? So this becomes our level order. But if I run this, it will run in infinite loop.
Stack empty. Is queue empty? We have to check.
Sir, is QMT we didn't see.
Where should I check?
Before DQ.
Before DQ we should check, otherwise DQ is going to assert and it will crash. So before DQing we have to check if is queue empty, queue break. That means we come out of this loop, right? So now this program will run, but it will crash. So what have we missed? Yes. So what we are doing is, if temp of left is null, we are putting that also in the queue. So next time the DQ will happen, temp will be null. Temp's data we are printing crash. So should we be putting nulls on queue? Doesn't make sense. So before enqueuing we will see if temp of left is not null, then enqueue. Just for first line I am writing, then same we will do for, because we want to check both of them. If left is not null, then we just want to put left. If right is not null, we just want to put right. Correct? So this way we are making sure our queue will become empty. Otherwise, in previous case, if we did not have printf, it would have been infinite loop, because every time we are putting left and right. Okay, not infinite. Here also it will crash, because null of left we try to access. After DQ, then also it will crash. So with this, it is addressed. It should work fine. Okay, close this so that we see. Code is fine. Before compiling and running, let's think about different test cases of level order traversal. Because main is going to call level order traversal. What are the interesting test cases?
Not unbalanced tree is one.
So let's take a simple example, 1, 2, 3. 2 is in the root, 1 is in the left, 3 is in the right. And let's trace in our mind whether it will work for that or not. So first time it comes, it creates a queue, root it enqueues. In our tree we have 2 in the root, 1 in the left, 3 in the right. So 2 will be enqueued. Fine. So we come here. Is queue empty? No. What we do? We dequeue. We get address of 2. 2 we print. Then is left of 2 null? No, because 2 has 1 as left child. So left is not null. We enqueue 1.
If there is only one element, then
Yeah. So we'll come to the second case. You're saying that is another test case. If there is one element, yeah, we'll come to that. First, let's trace 1, 2, 3 because that is one test case, valid test case. So we go to the left. One's address is put on the queue. Is right of 2 null?
No.
No, that has 3. So address of 3 is pushed onto queue. It's enqueued. So now queue has 1 and 3. These 2 nodes it has. So we go up. Is queue empty?
No.
No. What is dequeued?
1.
1. 1 will be printed. Is left of 1 null?
Yes.
It is null, so it will not enqueue anything. Is right of 1 null?
Yes.
It will not even enter this. So nothing gets enqueued. Now what is there in the queue? 3. We go up and we check. Is queue empty? No. We dequeued 3, print 3, nothing gets enqueued. We go up. Is queue empty now? Yes. We come out. Perfect. So Hemant said about second case, if there is only one node in our tree, that is another interesting case.
There is no root is also null.
If there is no node, that is also interesting case. So first let's see one case. First case of Hemant, we enqueue just root. If there is only one, we enqueue that. We go in the loop. Is queue empty? No. We dequeue. We print. Left child both are null. Left right both are null. We don't put anything. We go up. Is queue empty? We break. So that case is one node case is addressed. Now Sadhana is saying there is third case, which is if root itself is null. So let's trace and tell if there is any problem with that.
Initially, before enqueuing the root, we have to check if it is null or not.
Yeah. So we have made this this mistake here. Before even checking, outside the loop we may put null on it. So that is unaddressed case. Valid. So how should we address that?
After DQ, before DQ we can check.
Before enqueuing only.
Before
check.
enqueuing,
Why should we put a null? Before enqueue itself we can check. So shall I put here? If root equal to null,
Return.
don't enqueue or return.
Yes.
That we can do in the beginning itself.
Assert.
No, in level order, even if he is passing a null, we just want to come out. We don't want to assert because traversal is allowed with a null, but deletion is not allowed with a null. Or popping without putting anything is a wrong operation. Here it's not wrong. If person calls with null, we'll say there is nothing. We print blank. So here we say if. Generally we have handled this case in all the functions that we wrote. If root is null, for deletion we return null. Insertion, if root is null, we put a special case where root is updated. So here if root is null, we don't do anything. So putting it in first line has an advantage. We did not even get to creation of queue, destroying of queue, that is saved. If we put after create queue, that is what we were talking about, then destroy will not be called. That will be a problem. So here, putting it here would have been a wrong thing because we are creating a queue and we are returning. So if you are a developer, you leave this bug, your tester is going to file. I ran stress test for 2 days, my system memory was full. Some problem in your code. The stress test is a test that you continue for a longer duration. So you are exercising the system, level order you are calling 10 times a day, 15 times a day by doing different insertions, deletions. So system memory will go up. So when we run those tests, we monitor system's health. If memory goes beyond this point, if processor consumption is beyond this point, then alarm us or send a mail, send an SMS. The system is under a bad condition. So that's how the bugs are found in real world. So just move it up. So allocation, deallocation, whenever we are dealing with, so it's a good check to make. Are we allocating something that we have not deallocated? That we should ask ourselves. Now let's make it fine. Now we are all set to call this function, or anything else is missing? So for compilation, we do our general 2 checks. Have we have we used a variable that we have not declared? Here we use just one variable temp, another is q. Both of them are there. Q is declared, temp is declared. Are we using any file, any function which is in a header which we have not included?
STD
stdlib. What is the function we are using from stdlib?
null we are using.
Null we are using. So null we are using, so there will be a problem. So we should have stdlib. Are we using any other function which is there in a header? Printf we are using. Which header contains that? stdio.h. So that also we should put. And today we'll see, are we smarter than compiler? From our side we are making sure with before hitting compile button that we address all the issues. Anything else? Free we have done by calling destroy. Should I compile? Fingers crossed. Let's see. Perfect. So now you have reached to a level of perfection. The only thing missing is we want to call level order. From main we have not called it. Let's call level order traversal and say root. One more thing we'll do in level order, because it is going to print all in one line. Let's add a printf on top. And let's put a new line here, so that anytime we call level order, it prints in new line. So this will just print a line. So even if a tree is blank, it will print level order and nothing will come in front of it. So with this, let's run our code. So for this, level order should be 2, 5, 3, 4, 9, 1. That is what it is. Done. So now we come to second traversal. Now all three traversals that we are going to do, in order, pre-order, post-order, that will be using iterative, and it will be using which data structure? Stack. So that is the next function we write.